Okay, so welcome to the 22nd class of our computer architecture and organization. So, the last class we have stopped here now. So here we are discussing about pre-indexed addressing modes. Okay, so as we have discussed in the previous class that there are generally three types of addressing modes. One is pre-indexing addressing mode, pre-index with write back, post-indexed. So first we have discussed about pre-indexed addressing mode. Okay, so pre-indexed in this pre-indexed addressing mode, we have taken an example for a example of load instruction. See here, if you observe LDR R2 comma content of R1 comma hash 12. So this is an example for pre-indexed addressing mode. Okay, so here 12 is nothing but an immediate offset value. Whenever you encounter with a hash, it indicates that it is an immediate value. So what is the thing that we need to do whenever we encounter an expression like this? Then we need to add this particular immediate value. Whether you can add or subtract this immediate value within the register, other register. Generally, 99 cases will perform add operation only. Okay, na? So here we will add the content, the register contents in the register R1 with the value of 12. We will add the contents in the register R1 with a value of 12. Okay, now next, whatever the value we are going to get, that will be considered as address. For example, see here in this example they have given, see the value of R1 is 188 and here it is 12. So what they have done, they have added 188 and 12. So whenever I perform an addition of 188 plus 12, I am going to get 200. I am going to get 200. Okay. Here in this case, see, it is just for an example. So they have taken this 200 as an exact as a decimal number, and they have even shown the memory locations in a decimal number also, not in a hexadecimal. So if you consider 188 plus 12, it is a 200. So 200 will be considered as an address. 200 will be considered as an address. This address was generated by adding the contents of the register R1 with 12. So 12 plus R1. R1 is 188. So 188 plus 12. The total value is 200. Okay. So whenever if you encounter this content means 200 should be considered as an address. Okay. So in this particular address of 200, we get 27 as a value. Okay. It is an assumption. Here in this example, I have written 27. In some examples, you may take 30 or whatever it may be. Okay. So this 27 is going to be loaded. Where it is going to be loaded, as we have discussed previously, that whenever we encounter load instruction, that means the transferring of data will take place from a memory location into a register. Here, R2 is a register, isn't it? This entire thing is a memory location and R2 is a register. Here, this particular 27 value is going to be dumped into a register called R2. So here, if you observe here, the 27 value is dumped into a register called R2. So this is the about pre-indexing addressing mode. Pre-indexing addressing mode. Okay. Next, we are moving to the next topic. Okay. Next slide. Yeah. Now, once again, we are going to discuss about what is the difference between pre-indexed and post-indexed addressing mode. See, this is the example what we have discussed previously. This is an example for pre-indexing addressing mode. Here, whatever the thing that is present, the entire thing will be present in the square brackets itself. Okay, that means here first the content of in the register R1 is going to be added with a value of 12. That's what we have discussed in the previous example. In the previous example, we have taken in the previous example, we have taken R1 as 188 and this 12. We have added these two things. So 188 plus 12 means we have got 200. That 200 is considered as an address, and whatever the value that is present in the 200 address. In the previous example, we have 27 in this particular address, okay, that value is being moved into the required register or not, or destination register or not. That means I have this, consider R1 as 188, then this 188 is being added with 12, so altogether I will get 200. That 200 will be considered as an address, and whatever the value that is present in that particular address, in the previous example we have thought it is 27, that 27 is being moved into the destination register to what was given here. Here R0 was mentioned, so the 200 was being moved to the R0 register. So this is pre-indexed. Okay. Now we are going to discuss about what is meant by post-indexed. Okay. So here pre-indexed. Pre means before. Add offset address before the memory access. That means first of all, this is called offset address. First of all, I am adding this offset address to the register. I know then the total value will be considered as an address. Then only I am moving to the value from this particular address. But post offset address means here this is an example for post offset address. The basic difference is here, see, the parentheses or square brackets are only for R1, and here the 12 is being separated from that square brackets. Okay. So what is the difference between these two things? Means here post indexed means post means after, pre means before. So add offset after the memory access. That means what we are trying to do here, R1 is a register. Consider R1 has a value of 100. Consider R1 is having a value of 100. Then what I need to do, I will replace this R1 with 100. I will replace with this R1 with 100. Okay, so then how it will become LDR R0 comma content of 100. Okay, now this particular 100 will be considered as a address of a memory location. This particular 100 will be considered as a address of the memory location. I will search where is that particular 100 memory. Here it is the address, that particular 100 address. Okay, whatever the value that is present in this address, first of all it is going to be transferred into R0. That means, for example, I am having 20 here. Okay, that particular 20 is being, if not 15 here, 15. That particular 15 is being moved into R0. So now the value of R0 is going to become 15. Okay. Next here, after performing this, what I am going to do? Now I am going to add this 12 to this 15. See, what is that? You can easily observe the differences between this one and this one. Here I have added this 12 to the content to the R1, and the total value what I got, that means I need to move to the previous slide now. See, I have considered this entire thing as a single address. That means what I have done, I have added this R1. I have considered R1 as a 118, and I have added this 12 to this 188, and I got 200. That 200 has been considered as an address, isn't it or not? So whatever the value that is present in that particular address, it is being transferred into, or it is being loaded into the register R2. Okay, now. So, but now if you observe here, post index, now what I am doing, I am just considering, for example, consider if R1 is equal to 100. Okay, then what I am doing, or else for your simplicity, what I will do is, I will take R1 is equal to 188 here also. R1 is equal to 188. Okay. Now I am not adding this 12 directly. Now what I am doing now? Now I am considering this 188 as an address. Okay. So where is that 188 address? Here. Okay. Now what I am trying to do, whatever the value that is present in a 188 address, that is being transferred into the register or not. Okay. For example, I have 20 at that particular address. I have 20 at that particular address. So that 20 is going to be moved into this register. This 20 is going to be moved into this R0 register. Okay. After that, what I am doing, I am adding this particular 12 to the 20. I am adding this particular 12 to the 20. Okay. Then how much I am going to get? 32H. Okay, so that means the R0 is going to be updated with a new value called 32H. Okay, so that is the difference between pre-indexing and post-indexing. In pre-indexing, whatever the value we are going to add, that entire value will be referred as a address of a memory location. But in post-indexed, only this will be considered as an address of the memory location. The value that is present in this particular R1 will be considered as an address. Whatever the value that is present in this particular address, it is going to be transferred into R0. Okay, and after transferring it, I am going to add this particular 12. I am going to add this particular 12 to the R0. 12 to the, sorry, not to R0, but 12 to the R1. Sorry, I think it is wrong. Sorry. So here I am going to update R1. That's all. Okay. So that means what is the thing? I am just adding R1 with the 12, and I am going to change the value of R1 register. That's all. Okay. So that is the difference between these two. Pre-index with write back addressing mode. Okay. Here, write back means we are going to again represent our writing the, we are again once again writing back the value. Where we need to write back the value? We need to write back to the value to a register called Rn. Okay. So the effective address is written back to a register called Rn. This is called pre-indexed with the write back addressing mode. See, these are examples. Okay. One is with write back and fixed offset. Here we are having two examples. One is load and other one is store. First one, load rd comma content of rm comma k. Second one, str store rd comma content of rm comma k. Okay. Here, what is the thing you need to do? Is here we are having two registers. One is rm and the other one is k. Okay, now k is nothing but offset value. K is nothing but offset value like hash 12, hash 15, what we have discussed. Okay. Here, what is the thing that is going to happen? The value that is present in the RM is going to be added with K. For example, if K is equal to 12 and the RM is equal to 188, both are going to be added. Then I am going to get 200. Okay. So then I am going to get 200. Okay. That way, that memory location I will go and I will get the required value. So it is very similar to the previous one. But the only difference is see here, what is the only difference between this one and the previous one is here we will add these two values. Well and good. One copy, that means for example 188 plus 12, the answer is 200. We'll go to this particular 200 memory location, and that particular 200 value is going to be again updated by in this RM. If you observe here, there is a feedback path. That means whatever I add, whatever the answer that I am going to get, that answer is going to one, what we call one copy will go to the memory and the other copy will transfer again and comes to the RM register. Okay, now? So it is called write back. I am writing back again the result here. So it is called write back. That's what they have mentioned here. The effective address is write back to Rn. It may be Rn or Rm, it is not a problem. Here, this is a register. Okay. Whatever the value I am going to get, for example, consider here please consider it as Rn. Okay, Rn is equal to some 120. Okay, and comma k is equal to 50. Okay, whenever I perform the addition between these two, that means 120 plus 15. How much I am going to get? I am going to get 135. Isn't it or not? So whenever I perform this addition between these two things, I am going to get 135. Okay. that particular 135 is there now, it will be, so here that 135 will be considered as a address, and it will search for that particular 135 address where it is present. For example, it is present here, then our controller will come to here. Okay, similarly this RN register is there na. Previously RN has 120 na. Now this 120 is going to be replaced with this 135. That means this previously I have RN is equal to 120, but now this particular RN will be replaced with 135. That means what is the thing that is going to happen here? Here we are going to write back the value again to the RN or RM. That is not a problem. Here it is RM. It is just a spelling mistake. So we are again writing back the result to that particular register. This is nothing but a feedback. The small amount of the output that is given as an input is called feedback. Okay. So this is called write back addressing mode. Okay. Not responding.